I've got a whole suite of science experiments, observations, or demonstrations, whatever you want to call them, and they have been uh, put on the web, on NASA websites, and they're called Saturday Morning Science.
Right.
Yes.
And then APS, the uh, American Physical Society, hosted a number of my experiments for my last flight, and they call it physics off the sphere.
Yeah.
So if you check either one of those places through your favorite search engine, you'll come to a number of these educational scientific videos. And for example, I flew yo-yos, and
Mm-hmm.
the physics of a yo-yo involves, oh, there's what, yeah. So the physics of a yo-yo involves alternating kinetic and potential energy, but you get in an environment, in a weightless environment, now there's no potential energy.
Yeah.
And so it all has to be kinetic energy in the form of either angular momentum or linear momentum. And there's a lot of really cool physics behind something as whimsical as doing a demonstration with yo-yos.
And I'll put a couple clips from that video actually in this episode, because not only were you on the space station inventing a zero-G coffee cup, you invented quite a lot of yo-yo tricks that can only be done in space as
Yeah,
well.
and so imagine the yo-yo trick where you throw the sleeper out and you let it crawl across the carpet or
Yeah.
something.
Yeah.
That's called walking the dog, and it's one of my favorite tricks. But in weightlessness, you could throw a sleeper out and you could have it go across the ceiling. And so I call that the fly walk.
So cool.
So here, spin a yo-yo. I'm going to do orbit the Earth. There we go. And it's orbiting slowly, but it's spinning fast. And then I'm going to do around the moon. Look at that. And then I'm going to do the tether assist. Now normally we'd call that man on the trapeze, but it won't catch. And so it just bounces off the string. And it's kind of like the tether technology we use for satellites and things. So I call that the tether assist. And let's see if I can get it to come back now. There we go. And because I'm in space, and I get to name these yo-yo tricks as I invent them. So I call this shoot the planets. And I'm spending more time training to fly the robotic arm so I can snag this little spacecraft coming up here in a week or so called Dragon. And I haven't been spending as much time as I should working on my yo-yo training. So I've been ignoring my yo-yo training. So it may take a couple of times to get this trick correct. And it just shows that I've got misplaced priorities. Here we go. Oh, so far so good. Orbit the Earth. And now, so I'm keeping it moving in an arc. There's 2, there's 3. Oh, how about that? Let's see if I can get it to come back. Oh, okay. So now it's spinning really fast. We're going around. Oh, I like this. I'm going to do shoot the planets again. So there's that, and there's that. There. That was a good one.
So cool. We love, on this show, we do a science segment every single week. We love science. We actually talk about what NASA's doing and what different things from space exploration is happening almost every single week. And I love that you were doing like these Saturday morning science segments up on the space station too, which is so great. Did you, outside of the stuff that you invented, was there any experiment that you were really jazzed about working on, either when you were there in Expedition 6 or 30 and 31? Was there one that you really loved?
Yeah, there's, most of the experiments on space station are programmatic in nature. They're well planned. They're well thought out. They're vetted through peer review on the ground, and they result in scientific peer-reviewed publications. And there's a whole suite of topics, from fluid physics to crystallization to life sciences,
to human physiological experiments. And probably the human physiological experiments are the most useful in terms of helping people on Earth, because we're humans, and to learn about human physiology in an environment where human beings were not innately meant to go, you can learn things about your body. And an example is the bone decalcification. And we have an empirical solution for that now, which is exercising really hard, and that'll keep your bones healthy. And this is akin to sailors going on oceanic expeditions in the 15th, 16th, and 17th centuries, and succumbing to scurvy.
Yeah.
It's like, scurvy was this mysterious disease, which nowadays the solution for scurvy is trivial. It's vitamins, but nobody had even discovered vitamins. The word vitamin didn't even get coined until around 1915.
Wow.
And so people were dying from these mysterious diseases when sailors would go off on these ocean voyages, and they learned an empirical solution. A guy by the name of James Lind, a British a naval surgeon, figured out if you suck on citrus, you won't get scurvy.
Yeah.
And thereafter, scurvy was no longer an issue for sailors, or it shouldn't have been, but they didn't understand vitamins and diet for about another 100 years. And so we're reliving this on station right now with bone density. You go into space, your bones start to decalcify. That's not good if you want to come back to Earth. And so we exercise really, really hard, and now your bones don't decalcify. So that's the equivalent of sucking on citrus. But we're still doing the fundamental research to figure out why biochemically your bones decalcify, and how can we keep that from happening. And once we understand the basic biochemistry of that, that's going to help everybody on the planet that doesn't have an opportunity to go into space. So it's the same story, different venue in terms of discovery and human physiology in using environments where we weren't innately meant to be. And we learn these things literally from the souls of those